Hello class, welcome back. Today we are going to be talking about sections 1.2 and 1.3, which include both adding and subtracting integers. Now I'm going to warn you, this is a bit of a tough topic. A lot of times it can be a little bit confusing, so please make sure you're paying close attention. Remember, you can pause or rewind the video at any time, and also make sure you have your paper and pencil out for notes. So you can make some notes of strategies that work best in your brain and have some examples to reference back to, okay? So I'm gonna go over a bunch of different strategies with you guys because oftentimes different strategies work for different learners. And hopefully by the end of this lesson, you will have something that helps you be successful at adding and subtracting integers. All right, so before we get started, let's first address the essential question for today. And that is the sum of two integers positive, negative, or zero? How can you tell? All right, and we are going to be addressing that shortly. And first thing we're going to start with here is adding integers with the same sign. Now, as you see written right below that, there is a rule, but I don't want to read this rule quite yet because what I think happens is sometimes we read rules and we try to stick to them, but I think it's better to conceptually understand something first, because when we're taking a test or when we're doing a worksheet, we don't want to just try to remember rules. We want to actually understand something fully. So I'm hoping that these strategies help you understand it fully first, and then maybe once we're more comfortable, then we can use a reference of a rule. All right, so this first question says, example, find -2 plus -4. Now, we're going to differentiate these types of integers, the positive ones and the negative ones, by creating models to represent them. So in order to represent the negative, I'm going to write it in this top corner. I'm going to use a counter that looks like this. It's going to be this pink circle. Okay, and if I really wanted to, I could put a little negative sign in there. And then to represent the positive, I'm going to use a green circle. And like I said, I could take the extra step and put a little plus sign in there as well. But those are going to represent our integer counters, and this is one strategy that is going to help you add and subtract integers. And in this case, it's especially good to start with because it helps us kind of understand the formulation, conceptualize what's going on here, and then once we feel more comfortable, maybe we don't even have to draw models anymore. We can just maybe do it mentally or just do it quickly because we understand how it works, okay? So this is the first strategy I'm going to show you, is integer counters. So we want to represent both -2 and -4, right? Those are both negatives, so those would be both represented by our negative integer counters, correct? Maybe I should make that pink instead then. And I'm going to draw 2 circles to represent that -2. And then we wanted to add 4 of the -4s. Now in this case, these are all the same sign. So we would just simply count them up, and that would give us our solution. I'm going to put the negative sign in there, and it's really as simple as that. So we're going to count all of these, and together it's 1, 2, 3, 4, 5, 6. So our answer would be -6. Now that might seem easy right now. I'm going to show you a different method to solve that as well. So I'm going to make a number line because I want to show you an alternate method. All right, so this method is using a number line to actually determine what your solution is. And we're going to use our knowledge from the last lesson on this because we want to make sure we know what happens when values go to the right and what happens when values go to the left. So if you recall, you should know that as values move to the right, they're increasing, and as values move to the left, they're decreasing. So I'm going to start with -2, -3, -4, -5, -6. I do -1, 0, 1. Okay, so I'm drawing this model right here for you. And since this says find -2, we're going to start right there at -2. So I'm going to mark that spot for you. We are right here at -2. And now we are adding -4. Now this is a part where some people can get confused, because when they're using the number line model and they're thinking adding, they're like, well, I know when we go and move to the right, that's positive, right? The values increase that way. And when we move to the left, the values decrease, right? But this is what I need you to think of. I need you to think of the entire picture because we're adding -4, right? So that means if we're adding a negative, we are actually moving to the left, because what I'm going to teach you shortly when we move to the subtraction section is that adding a negative is actually the same thing as subtracting. So we are going to move back to our -2, and in this case we want to move -4, so 4 to the left. So we would go 1, 2, 3, 4, and we would end up right here at -6, and we would also agree that our solution is -6. Okay, I hope both of those models worked, or at least one of those models worked in your brain. And now I want to discuss the actual rule that was given to us here. So anytime we see that the sign is the same, the rule says to add the absolute value of integers and then use the common sign. So remember, this is only when we can address both signs are the same. So here we knew this was -2 and we knew it was -4. Those signs were the same, so we could take the absolute value of -2 and -4 and add them, and then we just apply that sign at the end. So here I would already put a negative sign in my solution because I know it has to be negative since that's the common sign. And this would be 2 plus 4, and then that would be -6 since that was our common sign. That was the rule, right? Common sign. So I hope one of these 3 strategies works in your brain. Let's move on to get a little bit more practice because, like I mentioned, this can be a little bit confusing. So let's go ahead and move on. All right, now in this case, we're talking about adding integers with different signs. So kind of like I said before, let's worry about the rule at the very end. But first, let's start to use the same models we just used to see if those work better in your brains as well, right? So we already made our colors. Remember, the pink was the negative and the green was the positive. And here, I know this is +5 because it doesn't have a sign next to it. So positives don't always have to have a sign next to it, but they could have a positive sign next to it. Negatives always have to have that negative sign next to them, okay? So I'm going to draw 5 integer counters that are green. 1, 2, 3, 4, and 5. And then I'm going to draw 3 of those that are pink. 1, 2, 3. Now, what I'm going to teach you about right now is something called an integer pair. And what an integer pair is it's when a negative and a positive pair up. They're known as opposites, and those opposites actually cancel each other out. So this would be 1, 0 pair, this would be 1, 0 pair, and this would be 1, 0 pair. And like I said, they actually cancel each other out. So I'm going to do this in a highlighter so you can still see what's going on, but I'm just going to cross those out because they are null and void. They cancel each other out. And actually, what we're left with now is just going to be those two. Oops, I'm so sorry. I completely mixed these signs up. So I'm sorry, these should have been positives, the green, and these should be negatives, my bad. And so what we are left with is positive 2. So this equals 2, correct? All right, don't you believe me just yet. We are going to use a number line as well to also show a different way of finding the solution there. All right, so we are starting off at 5. So I'm going to do 5, 6, 7, 8, 9. I'm going to go down the other way. 4, 3, 2, 1. I'm sorry that my number line is not scaled evenly, but a professional number line already would have been, so just disregard that. We're starting at positive 5 right here. And now we have to determine if we're moving left or right. I want to remind you one more time that when we move to the right, that's adding or increasing the value, I should say. And when we move to the left, that's decreasing the value, right? All right, so in this case, we are adding -3. So don't get confused and think we're going to move right, because it actually turns into a negative. And what I kind of introed to you on that problem before was when we have a plus and a negative next to each other, it actually can be turned into just a negative if you choose to do that. So -3. So in this case, we are going to move 1. Oops, I didn't want to use highlighter, but that's all right. We're going to move 1, 2, 3 to the left, and we are going to end right here at 2, and we agree that that is our solution. Remember, the last thing I wanted to do was go over the rule, and that says subtract the lesser absolute value from the greater absolute value. Then use the sign of the integer with the greater absolute value. So basically what all our rules are doing is they're trying to make this a little bit less complicated for you by making the signs go away, because the signs are where we make the mistakes, correct? So what we want to do is we want to forget about the signs, but in this case, we will need to know the sign that's greater, because that is what's going to be what is remaining for our answer. So subtract the lesser value. So we're always going to subtract the lesser value. So we would have the absolute values of 5 and the absolute value of -3. Oops, that should be a straight line. And we, of course, know those are always going to be positive, so it's going to be 5 and 3. And now we are going to subtract them, but what we did want to keep note of is using the sign with the greater absolute value. So we already want to put that sign there because we know that's going to be the answer. So 5 minus 3 is 2, and we agree that positive 2 also matches up with our answers up there, and 2 would be our solution. Like I said, different methods work with different brains, so if one of those really stuck with you, whether it was the integer counters, whether it was the number line, or whether it's simply using the rule, go ahead and run with it. I do want you guys to all try these different methods though to see what you're most comfortable with. Now we're going to move on and talk about some subtracting. So subtracting integers. This is something important. So we can turn all integer subtraction problems into addition problems by simply changing the signs. Now, we can't just change whatever signs we want to, so make sure you're paying attention of when we can change the signs. The only time we can change signs of a problem is when two signs are directly next to each other. And I'm going to show you when that is and kind of what that means. So I actually don't have an example right here. So I'm going to write another example in there because I don't see one with plus a negative, since that's technically already addition. But I do want to show you how the counter of that is applied as well. Okay? So example, find 3 minus 12. So like I said, I want to use the same method we did, the integer counters. So 3 is a positive. I'm going to underline that in green. 12 is a negative 12. There's a minus 12 next to that, so that's a negative 12. Okay? But we can also change that if we wanted to. Something that is equivalent to that is 3 plus negative 12. Okay? Plus and minus next to each other turn into a negative. Once we get into multiplication of integers, you guys will know that a positive times a negative is always a negative. But let me try to give you a real life example that matches along with that might help you. So let's say something good happened in your day and something bad happened in your day. This isn't necessarily our best human trait, but a lot of times what stands out more to us is the negative, is the bad thing that happened, right? So I got an A+ on my test in school, but then my friend Susie was picking on me at school. That is probably what would stick with me the most, right? I would feel bad about it. We tend to feel bad about things more than the positive. So when there's a positive and a negative next to each other, the negative seems to stand out a little more. So plus and minus next to each other, that actually is the same thing as just minus, okay? I don't know if that real life example helped you, but if it does resonate with you, then let it stick. All right, so I'm gonna draw 3. 1, 2, 3. Hopefully I remember this time that those ones are positive. And then I'm gonna draw 12 this time, negatives. 1, 2, 3, and I'm just gonna draw them next to each other since 1, 2, 3. I know 3 times 4 is 12, so I can just do 4 rows of those. And now I want you to use that same rule, which I told you about before, about the values canceling each other out. So remember, it's called a zero pair, and a positive and a negative cancel each other out. So these 3 are going to be no longer, they canceled each other out, they're gone. And now we're left with just 3, 6, 9 negatives. So in this case, we determined our answer is, I keep doing that, oops. We determined that our answer is negative 9. Let's test out that theory with our other strategies. Wow, I'm going to have to move 12. That means I'm going to have to make a long number line. So we're starting at 3. 2, 1, 0. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. It's not going to be long enough. I'm going to extend it. Negative 7, negative 8, negative 9. I apologize for the messiness, guys. And the thing about drawing your own number line also is that you may not draw it long enough. In this case, I already knew it was going to be the answer, so I kind of cheated a little bit. But let's see, if we started at 3, right here at 3, and then remember, this side increases, this side decreases. We have to go minus 12. We would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and ba-bam, we end up on negative 9 as well. Okay? And we can also use one of those rules that we used above. For example, we can use, in this case, these signs are different, correct? And the rule was when the signs are different, you're going to take the absolute value of both, but you are going to keep the greater sign, and you're going to subtract the bigger value or the smaller value from the bigger value. That means I would know my answer is going to be the negative, since the negative, oops, I didn't want to block that out. Since the negative is going to be the larger sign, because negative 12 is larger. So then I would just do 12. I would just do 12 minus 3. And I know that is 9. And then I would apply that negative sign since that sign was larger. And my answer is negative 9. Okay, we have 2 more examples to go over. I know this can be a little bit overwhelming, but stick with me, okay? We're almost there. Alrighty, find -8 minus 13. Wow, I really had to make a lot of drawing on myself, didn't I, with all of these big numbers? All right, so this is something I want to point out to you right here, because minus a negative, okay, what do we even do with two minus signs next to each other? Well, I'm going to relate these two minus signs to what's going on in our current situation right now, okay? So right now what we're doing, these two negatives have to be apart from each other because they're social distancing, right? But let's apply post-COVID or pre-COVID ideals to this. And if we were able to, and this is our friend, we want to hug our friend, right? So we're going to bring those together. So what I'm trying to say is that anytime you have two negatives next to each other, it is actually going to turn into one big positive. So forget the negatives are there, only the negatives in the middle, of course, and it just turns into one big positive. So that would actually be -8 plus 13 now, okay? I'm going to give you one more example of how that makes sense, and I'm going to use an English example. So let's say I said, I am not going to the party. So if I'm not going, does that mean I'm going or I'm not going? It actually means I'm going, right? It's a double negative, and double negatives oftentimes in English, actually, I guess they're not really a correct use of grammar, but they actually turn into a positive, just like in math. So if you said I'm not going, that actually means you're going, right? So basically, those two negatives turn into one positive. Yes, I am going. Okay? Hopefully that sticks with you. Just remember, anytime you see two negatives directly next to each other, they have to be directly next to each other. So this -8 over here is not impacted at all, okay? Because that's not directly next to each other. It's just when they're directly next to each other in the middle, and that turns into a positive, okay? So now we're back to adding -8 plus 13. Let's do our counters. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw a little bit faster now. And 13, holy moly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, the little lonesome one at the bottom. All right. Now, you guys already know what I talked about with zero pairs. We have 3 there, those cancel. 3 there, those cancel. 2 there, we cancel 2 more. And we are left with, when we count them out, we are left with 1, 2, 3, 4, 5, and that's 5 positives. So we would say equals 5. I can show you that on a number line. It's going to be a long one. So I'm just going to model it real quick. So if I was at -8, I would know plus 13, so I'd have to go 13 to the right, and I would end up at +5. Just take my word for it. And then let's use that last strategy of the rule. They are different signs, so that means we are going to take their absolute values. That means just the positives, 13 minus 8, and subtract. And we get 5, and we would use the bigger sign. In that case was the positive, right? So +5 would be our answer there as well. All right, remember you can pause or rewind if you need to go over that example one more time. And let's go back to our last one. We're almost there. All right, 5 minus -4. We just talked about this, right? Right now they're social distancing, but let's go back to a post or pre-COVID era because we want to hug our friends. Our friends are cool and we miss them, okay? So these two isolated peeps, they're going to hug it out now. And we're just left with 5 plus 4. Man, I really don't think you guys need integer counters for this one. But hey, just for the sake of it, let's do it. So I have the 5 there, and then 1, 2, 3, 4. They're all positive. I think you guys could have added 5 plus 4 by yourself without the counters, and it turns into 9. All right. In addition, we could also draw it on the number line. Why not, since I didn't do the last one? And I'm going to do 5, 6, 7, 8, 9, 10, 4. We start at 5, and we are going to move a positive 4. So 1, 2, 3, 4 to the right, and we end up at 9 as well. All right, guys, I hope this wasn't super overwhelming for you. Remember, you can pause or rewind at any time, and don't you worry, we're going to have plenty of time to practice and go over this in class. It does get a little bit confusing, but I know you guys are all going to learn it eventually using whatever strategy works best for you, okay? So go over these notes, keep your notes that you have, and remember, you can rewind at any point that you need to, and come to me to class tomorrow with any questions. We're going to go over this all together, so don't worry, okay?